Hey guys, I said I would create a short little screencast to talk about some of these multiple choice problems. I want to quickly run through the first one, number 5. For each of these, right, if I start talking about a problem, you should think about pausing me before actually you listen to me, right? So you can think about doing the problem and then you can listen to an explanation. Okay, so 5 has which of these statements is false, and the first 4 are all whether various limits exist, and then the fifth one is the function f is continuous at x equals 3, which this obviously is, right? As I'm approaching 3 from the left, I sort of approach whatever this number is up here. It looks like 5. And from the right, I also approach. I also am approaching 5, and the value of the function there is 5. So E is certainly true. So let's talk about the limits, right? For the limits to exist, it says nothing about the value at a specific point, just that the value of the limit as I approach from the left has to equal the value of the limit as I approach from the right. So even though at 2, for example, as we come in from the left, we approach 2, and from the right we approach 2, and the function itself is down here at 1. We don't actually care about that, right? The limit is 2 does exist, right? It as we approach 2, it is 2. The one that is false, I think, is as we approach 4, right? We're getting a different value from the left as we are up here from the right. So I think that's C. All right, let's talk about 6 next. Again, I'm only going to talk about the ones I think are interesting. Some of the derivative ones, you should be able to figure those out on your own. So let's talk about 6. That has the velocity of a particle is given by this function. And we want to know the distance traveled from this interval. T goes from 0 to 3. Okay, and so to find distance traveled, right, we have to do a couple things. We have to know its position function and did it change directions? Did it change directions in between that range, right? Because then we're going to have to add up multiple sub-intervals. So let's integrate this thing. Remember, distance traveled doesn't matter where I start, right? If this is the velocity and I start at 0, I'm going to travel the same distance as if this is the velocity function and I start at 1,000,000. So if we integrate this, right, we're going to get 3t squared minus 1/3 t cubed. And again, we have to think about whether or not velocity is 0 on that interval, right? Does velocity change signs? So let's quickly think about that, right? Does velocity change signs anywhere on this interval? So if I were to solve this out, right, I'm going to factor it, and I'm going to get 0 equals t times 6 minus t. And so my zeros would be t is 0 and 6. So no, it does not change signs on this interval. So we could have just simply taken the integral from the beginning, right? But we know that s of 0 is going to be 0. And s of 3, it looks like, will be, what is that, 27 minus 9. So I think s of 3 minus s of 0 is what we want. And that, of course, should be 18. I think I'm going to skip 7. Yeah, 9's kind of interesting. Okay, so again, pause me, work through 9. And then we can talk about it, okay? So while I write it, you could be working through it. So this guy's a piecewise function. We have x minus 2 on the top and x minus 2 on the bottom. And this is for x not equal to 2. This is k for x equals 2. Okay, so we have to find a value for k that makes this continuous. And of course, right, we have to, for this thing to be continuous, right, by the definition of continuity, right, the limit as x approaches 2 from one side has to equal the limit as x approaches 2 from the other side, which has to equal f of 2, right? That's sort of how we get continuity here. So because we have x minus 2 in both the top and the bottom, right, we're not going to have a sign change. We're not going to have any vertical asymptote where we go towards positive infinity on one side and negative infinity on the other side. So that's a positive, right, because they're both going to change signs. So I think this thing is just as simple as looking at this limit as x approaches 2. And the limit as x approaches 2 of of this function, right? Well, that's just equal to the limit as x approaches 2 of this function, which of course is just 5. So I think k should be 5 for that guy. Good. We'll keep rolling. We'll keep rolling along. Let's talk about 10. The area of the region in the first quadrant bounded by the graph y equals e to the x divided by 2, and the line x equals 2. So again, pause me, think about it, and then play me. Okay, so again, e to the x, we saw what e to the x looked like today, right? E to the x over 2 just grows a little bit slower, right? So that looks something like this. Right? And x equals 2, of course, looks like this. And so we are concerned with this intersection point, possibly, maybe not. Maybe this is so simple. So let's talk about that intersection point, right? If I plug in 2, right, this is 2 comma e. If you plug that into the first equation, right, and again, we are looking for this sort of shaded region. I have no idea where there it goes. We're looking for this blue region in here, right? Okay, so this is a simple integral to set up, right? We're looking for the area. We definitely want to do this vertically. We're looking for the area, and x is going to go from 0 up to 2. And what do we want the area under? We want x divided by 2, right? E to the x divided by 2. And so this one, we actually are forced to take this integral, right? This is one of the ones where you would actually do a u sub if you wanted to for 1/2 x, but we can sort of do this in our heads, right? We can say, obviously, I'm going to get a 1/2 coming down, right? So I'm going to need to multiply by 2, right? This is 2e to the 1/2 x. That's the integral, right? Because e to the 1/2 x will sort of just stay there forever, and we're going to keep on getting a factor of 2 out. And, of course, evaluated x equals 0 and 2. So that's 2e to the 1 minus 2e to the 0. Well, 2e to the 1 is just 2e, and this thing is just 2. So I think it's A, I hope. 11 should look very familiar because you've seen it before, I think. Some of you maybe. I'm not sure which version of which test that was on, but I'm pretty sure it was on a past one. 12, we're going to look using this u substitution. Again, pause me. Using the u substitution, let's talk about this function. And it tells us, like I said, the AP is very, very nice when it tells us what u sub to make, right? So it tells us u is root x, or x to the 1/2, depending on how you like thinking about that. Well, that means that du dx is 1 over 2 root x, right? 2 root x on the bottom. And it's asking us to plug this in, and this is one where it is forcing us to change our limits. So all of you people who wanted to stay in X land forever, too bad. Here we actually have to change our limits, right? So we're going to get something like 2 root x du equals dx, okay? And let's plug stuff in. So this is x equals 1, sorry. And now we want to find something out where we're in u land. Okay, so e to the root x, that's just, we can write that as e to the u. And dx, we know what that is. That is 2 root x du. And I have a root x down here. I think those things are going to cancel. That's going to be nice. So now we're forced to look at our limits, right? So when x is 1, when x equals 1, let's think about what this means. U is also 1, right? Because u equals root x. U equals root 1, we should say. That's just 1. And when x equals 4, u is root 4, and that's just 2. So my limits are going to be from u equals 1 to u equals 2 of this mess. And simplifying that a little bit, right, we don't actually have to take this integral if we look at the multiple choice answers. I believe this is just 2e to the u du, which I guess that's c, right? They pulled the 2 out, but, you know, it's the same thing. Okay, good. What do we have here? We'll do 13. We're on a roll, you know. So we have this function, f of x equal, ooh, that is not, a little brain fart there. F of x equals, what? F of x equals, there, we keep on trying to draw an integral sign. This is very strange. F of x equals 2 for x for x is less than 3. Less than 3. There we go. And x minus 1 for x is greater than or equal to 3. Okay, and so what does this function look like? It looks something like this. We're going to go up to 3 here at 2, and then we're going to go up like that. Okay, that's sort of what this function looks like. And we are trying to find, now I could draw my integral sign. Sorry for that. From 1 to 5 f of x dx. Good, good, good. And we want to find simply the area between 1 and 5 of this thing. So you could do this two different ways. You could simply do it geometrically and find this area and add this area. Totally fine, right? That would be, this guy would be 2 times 2, and this guy would be the trapezoid. So 1/2, 2 plus 4 times 2, I think. I think that would be that. Or you could divide this into two integrals. You could say 1 to 3 of 2 dx plus the integral from 3 to 5 of x minus 1 dx, right? And I think either way we should get 10. Either way, we're going to end up getting 10. Geometrically, this is much easier, right? This thing is obviously just 4. And then this thing is, what's this? This is 1/2 x squared minus x. 3 and 5. And you could take my word for it, right? This thing is going to end up being 10, but this is going to be 4 plus 25 halves minus 5 minus 9 halves plus 3 or something like that. And that is 10, right? This is 6. Yes, it's 10. Okay, 10 sounds like a good answer. Just a couple more. Ooh, 14 looks unpleasant. Let's do it. 14. No curly braces here that I have to draw. That is this thing, x squared minus 4. G of x is 3x minus 2. And then we're going to try to find the derivative of f of g of x at x equals 3. Okay, pause me. All right. So we know by the chain rule, right, that the derivative of f of g of x, right? Well, that's going to be f prime of g of x times g prime of x. Well, we can just do that, right? F prime, the x squared minus 4 to the 1/2, that's just going to be 1/2. And then on the bottom, this lovely square root, where instead of x, we have to plug in g of x. 3x minus 2 squared minus 4. That's f. That's the derivative of f times g of x, right? Then we also have 2x, right, because of the chain rule. So we'd have 2 times 3x minus 2. 2 times 3x minus 2. That is f prime of g of x, and then we just have to have g prime of x, which of course is just 3. So at 3, this thing is going to be what? This is going to be 1 over 2 square root 49 minus 4. God, I hope this is right. Times 2 times 7 times 3, I think. Okay. Oh, that's 45. Okay, so we'll get something nice. This is 21 over root 45, which is, what is that? That's 3 root 5. So I think 21 over 3 root 5, which is going to be 7 over root 5. And hope that's an answer. Yes, it is. Okay. We did this next guy. Yeah, we'll do 16, and then that'll be that. Okay. We'll do 16. So 16 says that we have some position graph, and our position curve, and it's given by this t minus a times t minus b, and a and b are constants. It says for which of the following values is t at, or values of t is the particle at rest. So when it's at rest, right, velocity equals 0. Velocity equals 0, and we know velocity is we could either chain rule this. I'm actually going to FOIL this out, right? It might be a little bit easier for us to see that. Okay, and so velocity is just a derivative, so that's going to be 2t minus a minus b. And when is that equal to 0? Well, this is equal to 0 when t equals a plus b over 2, right? If I get everything on the other side. So I think that would be b. All right. I hope this was somewhat helpful. And I wish you the best of luck studying. I'll be available via email if you would like to reach out.